occupancy types in that part of the code. And there are learning units for this course, so 1.5 AIA units if you need them, and we also have ICC units. And today, Grant, Murphy, and I are going to kind of run through the non-residential portions. I broke this out basically into 3 kind of sets, which is kind of an overview and high level 2025 changes, the mandatory measures that are impacted, and for new construction, the prescriptive and a little bit of the performance measures. The performance stuff I'll actually kind of mention in the overview, but for the most part, I'm going to go in the order of the code, the way it's written, just to help kind of organize everything and to help folks see where they can find the information. And if you don't already are not familiar with us, Grant and I are both CEAs, so Certified Energy Analyst through KBEC, and I'm also a licensed architect. And then through Imbalanced Green Consulting, we work with 3C Ren to offer code coach, answer code questions, and do education and outreach, like the course we're doing today. Okay, big kind of picture on the energy code overview and some of the high level changes, just in case you haven't heard yet. The 2025 building code will go into effect coming up in January 2026. So if you get your permit on or after January 1st, 2026, you're going to fall under the new code. And you can get those documents, take a look at what they're proposing or have authorized now for the energy code on energy.ca.gov website. And the process for adopting a new code is a multi-year process where there's input from stakeholders, ratepayers, and California is on a big plan to move us to more energy efficiency, but really reduce the pollution, reduce our carbon footprint, and to work on finding solutions that are cost effective and do all that at the same time. So this update is done every 3 years. And the process for this particular code cycle started in March 2022, and this will end when we finally get everything kind of published this year, and then code starting in January 1st, 2026. So big picture goals for the 2022 code, which we're currently in, and then kind of a little bit on the 2025 code update, is that the CEC has been encouraging the use of heat pump technology for space heating and cooling and water heating. And they've been establishing electric ready requirements for the single family and multifamily projects, expand the PV systems and battery storage standards, and strengthen our ventilation standards for indoor air quality and better alignment with ASHRAE. Those goals still continue. And then in the 2025 update, they've been looking at ways to save water and reduce energy in homes and non-residential buildings because of this energy water nexus. So more specifically, there's new references to following the plumbing code for pipe sizing, for example, and there's new requirements for chillers and cooling towers that use water. And that's just a couple of the ways with this energy water nexus that we're trying to save energy and costs. So these proposed standards for 2025 are estimated to provide $4.8 billion in statewide energy cost savings. For our kind of high level change and some of the things I'm going to touch on today, is that there is a new performance method metric, which we're going to touch on first. There's electric readiness now for commercial kitchens. Our HVAC, heating, ventilation, air conditioning, heating types, and our ventilation, the DOAS outdoor air systems, those for the prescriptive kind, and what's also used as the baseline performance has been expanded. Our exhaust systems, there's been some addition for animal and veterinary practice. And then for the envelope, there's been some new mandatory measures where the insulation in our walls, roof, ceilings improved a little bit for the, sorry, I said mandatory, but improved for the prescriptive component of it, which becomes the baseline for performance, but also a mandatory measure that includes vestibules, which we'll go over, and then our photovoltaic or solar PV and battery systems. Those formulas have changed a little bit and it's been expanded. So if you're not that familiar with the energy code, there's our regulations. We have something called reference appendices, and then there's manuals that go along with those two documents, the standards and the reference appendices. And inside those manuals, if you really want to dig into the energy code, that's where you can read up and it'll kind of explain and give examples of how to comply with some of the features in the energy code. And then under the 2025, all these things are in the process of being updated. And I think all of this is going to be published by June or July of this year. The kind of big picture organization, as a reminder, is that the standards are kind of divided into all occupancy mandatory measures. And then there's three big groupings of subchapters, one that deals specifically with multifamily residential, one that deals with single family residential, and then the grouping that deals with non-residential, which is what we'll work on today. And also new to the code, just a clarification, is that they've now specifically called out L group or laboratory group to have a better consistency with the overall building code. This table is in the beginning of the energy code. It's table 100, and it helps a person see where they need to go for certain occupancy types and the application. And then if it's a mandatory measure, a prescriptive, or performance, or if it's addition, alteration. This table has existed in the code for a while, but I point it out because if you don't know about this table, it is a good way to start to understand how the energy code is organized. And then this particular version of the table in the 2025 code, they included the demand responsive controls, which that section of the code already existed. It's just they hadn't included it in the table, so it was hard to do this easy table lookup to see where to go. So now that's inside there with references. And as we read this, everything that's double underlined or underlined means it's new. It was put into the code specifically for the 2025 update. And then when the final version is published, all those underlines will go away. Before we go further, I need to remind everybody again that mandatory requirements are energy efficiency measures that are applicable to all projects. And then we have what's called the prescriptive component packages. And these say, okay, you have to follow the mandatory requirements that are applicable, Plus, you need to follow all the parts of the prescriptive package. It's like following a checklist or following a recipe card. And then that kind of recipe card or checklist approach, that building is used as the baseline for the performance method or the computer modeling method. And again, all the mandatory requirements or minimums are applicable. But now with the computer method, you can actually do trade-offs. So you'll have your baseline building that's based on the prescriptive component package, and then you'll create in the computer a proposed design building that may have more energy savings in one area or one aspect of the building, and you can offset that if you have less energy savings in another portion of the building. And those kind of regulated energy uses that we model is our space heating and space cooling, ventilation for fresh air, but also the fans associated with the ventilation and our HVAC, water heating, indoor lighting, our solar PV and battery, and then certain covered process loads. And those process loads, we'll kind of hit on some of those that are included in there. And with this, you can use community shared solar or battery system to meet some of these requirements. So I just want to point that out as more and more communities are doing that. Now, under our current standards, we have two metrics that we need to look at. One's are called source energy, and the other is TDV, or time-dependent valuation. We've been using time-dependent valuation for the energy code for a number of years now. And that is still the way we're doing and looking at our Title 24 and the performance modeling. Under the 2025 code cycle, however, we'll still have a source energy, but now we're going to be dealing with what's called long-term system cost, or LSC. And now all the electricity, gas, or propane used within the modeled buildings are going to be converted to this long-term system costs. And similar to DDV, there still will be an efficiency measure and a kind of a sum or a total measure that includes all those regulated loads we talked about, the space conditioning, water heating, your ventilation, and also the total will include those photovoltaic energy storage, your lighting, demand flexibility, and some other plug loads. So what this means practically speaking is, for example, if we're looking at an office building, currently you put it in for permit, your energy consultant's going to let you know how the TDV, in other words, how your efficiency metric is doing. And if you have a standard design, proposed design, it says pass, okay, you're good. And then the total, all those energy saving components together, all right, including the PV and the solar for batteries, you pass. And then you've got your source energy, which is like was a proxy for carbon metric. If that passes, you pass. Okay, good. Now it's just going to look a little bit different next time you get these reports. When by next time I mean January, after January 1st, 2026. Now those elements really are just going to be replaced by that long-term cost savings metric for the efficiency, but that long-term cost savings for total and a source energy. And the same idea that if all three of those pass, your project passes. We don't know yet. Grant and I haven't played around yet with the software to see what kind of impact or what the numbers will look like with these new metrics. But conceptually, I mean, this part is still the same in terms of 3 metrics. They all need to pass. One deals with efficiency, one is the total energy, and then source energy, really accounting for fossil fuel in the mix and that impact it has on carbon reduction. And all this is to really help California move towards cost-effective solutions. And Grant, feel free to jump in if there's anything or any questions.
We haven't had any questions yet. Feel free to chime in if you guys need clarification on anything.
Thanks. Okay, under the mandatory measures, this includes all occupancies, but then also we'll go into the mandatory measures that are specific to the non-residential occupancies. I'd mentioned that laboratory got added to the scope of the energy code. And so kind of the main takeaway here is that the 2025 energy code updates are intended to add consistency with the other parts of the building code, the other parts of Title 24. So something to be aware of, but not really earth-shattering. In terms of, how much fun it is to comply with the energy code. But just to clarify what and how the definition of laboratory occupancy or laboratory group is defined, if you want to read that definition, you actually need to look under non-residential function areas. And then in that part of the definitions, then you'll see where these are defined. And in some cases, you may have to dig in deeper to know which part of the code's going to apply if your laboratory space, for example, has hazardous materials, because we also have the air occupancy category for hazardous materials. So it's going to depend on how much of the materials are being stored, and you'll have to dig in deeper to know. And basically it's going to follow the building code's definitions on these occupancy types. I'm not going to read it like every slide for you, because you're going to get a copy of the slide deck, and then you could go back and dig in a little deeper. But I'm going to kind of give you a high-level view of this material. So if there's anything that you want me to stop on or look at a little more, just let us know. There's a number of definitions now that have been added that are specific to mechanical equipment, specifically hot water heating. But in this case, it could also be hot water heating and space heating. So the reason it's defined is because then these pieces of equipment are then mentioned as part of what's now allowable under the prescriptive. So air to water heat pump in the code, you're going to see it written as AWHP. And then in the definitions part of the code, it's going to tell you that air to water heat pump is a heat pump system. It's a split system. It can contain one or more compressors, and there's a heat exchanger, and it's going to create hot water and or cold water, and it's going to can circulate that either hot or cold water into your air handlers or into different indoor units for space conditioning. It can also be used with the heat exchanger for heating your hot water. This is just an example of a residential scale. These are also referred to as monoblocks. And this has some advantage because instead of sending refrigerant throughout a building, now you're just sending hot or cold water throughout the building. The definitions of heat pump water heater types have been expanded, and we're used to thinking of and how I've always approached it was you had an integrated heat pump water heater, such as those, where the compressor is on top and the tank of the water's on the bottom, or the small commercial version, the compressors are in front of the tank with the tank right behind, but they're connected into one piece. So that's sometimes called unitary, sometimes called integrated heat pump water heater. And then there's split systems, which all the rest of these heat pump water heaters are an example of. And they're now the energy code's just clarifying, they're further defining that as a split system that's refrigerant, sending refrigerant back and forth between an outdoor unit and an indoor unit, or a split hydronic, where the outdoor unit, like the monoblock we just looked like, the outdoor unit has refrigerant in it, but it puts that heat energy into water, making hot water. Then that hot water goes and circulates into the tank or the rest of the system. And there's such things as multi-pass and single pass. This give you an idea of now what they're gonna, just to clarify, okay, an example of a split hydronic heat pump water heater system is the Sanco 2 units, where you've got your single pass heat pump compressor units outdoors. And then now they're using a hydronic circuit. So there's insulated water lines that now take that energy to the tanks. The next definition that's important to just kind of keep in mind, again, because it shows up now, they're defining these things because they're using these now in the code updates. And that's to define a commercial kitchen, because commercial kitchens now have a electric ready requirement. So it's okay to design that commercial kitchen with all fossil fuel appliances. However, you have to make way and make the conduit for electric ready, for induction and other electric cooking. And it just clarifies here if it's institutional or quick service commercial or your full service commercial. And then these would be electric ready in the future. Now we're going to get into kind of after we went through the definitions, now we're going to get into where these definitions are actually being applied in the energy code. So under the 2022 energy code, we had talked a lot about increased efficiencies for the HVAC equipment, for cooling systems, furnaces, boilers. And we had mentioned that there were new tables now for DOAS systems, or dedicated outdoor air systems, and computer rooms, and heat pump and heat recovery chillers. Well, all these things are still in the code. And now for the kind of the updates, there's sort of three main mandatory measure areas that have been updated, and that's like space conditioning equipment, the water heating, and then a little bit about the pool and spas. There's some minor tweaks here and there on some of these other features, but most of this has remained really pretty much the same. So with that update for the space conditioning equipment, kind of big picture is some of the appliance tables were removed, and some of the tables were updated to meet the federal minimum efficiencies, but there are some new tables for heat pump and heat recovery chillers, and updates for cooling water tower quality and properties. And kind of the takeaway with that is that because cooling towers use water, they're looking at making those more energy efficient and also more water efficient for that type of system. And then there's updates to the service water heating, which we're going to talk about in the detail. And then there's been updates on your pool and spa systems, where there's now a category for how you should size the heat pump that would be used for heating your pool and spa system, some updates on efficiencies, and updated joint appendices that really go into it. So if you're working with pool design, you'll want to review that for the new code. The service water heating, specifically the installation of heat pump water heaters, is where there's kind of this big change that we're going to go into. This section for service water heating has always included your temperature controls, hot water distribution system, insulation, et cetera, but now they've added item 7, specifically the air source heat pump water heaters, HPWH is how you'll see it in the code. Some of this stuff was recommended guidelines. A lot of this information you might have seen in the prescriptive part of the code, and now it's moved to a mandatory measure. So what was happening with heat pump water heaters is that there were a number of guidelines to follow and kind of recommendations and design considerations. And the California Energy Commission determined that a lot of these things were not being followed very well. And so there was much room for improvement on heat pump water heater performance. And as a result, a lot of these kind of design considerations now, some of these got moved into being mandatory measures. So specifically, the amount of volume, cubic feet, the volume that a heat pump water heater needs to function well. And a lot of the units, the newest, might only need 450 cubic feet of volume, but many of them still need 750 to 1,000 cubic feet volume of space to work well, or you have to use a ducted vent kit. And a lot of the units could only operate in 45-degree cold temperature, but now some of them 37-degree temperature. So some of these things now have been moved to mandatory requirements. One such mandatory requirement is that there has to be a backup heat for your heat pump. In this case, with the integrated tank type, they have electric elements, but there are some brands that don't have those electric backup heating elements in their heat pump. So you need some kind of backup. And then the tank needs plenty of air volume to have the air available to extract the heat out of the air to put it into that hot water. And so that's kind of spelled out a little bit more. And the way it's spelled out, though, might be, if you read this, it might be a little pause for thought, because they say, okay, you need greater of 100 cubic feet per kBTU per hour of compressor capacity, or the minimum volume provided by the manufacturer. Okay, so you might be wondering, what is the kBTU per hour of compressor capacity? I'm going to give you a little thumbnail to remember. And then if you're going to use louvered doors for how this heat pump can communicate with the rest of the house or rest of the space, to include that as part of this overall volume, then there's a formula where you would have 125 square inches plus 25 square inches per kBTU hour compressor capacity. So that metric again. And then I'm just going to in case you need to do some rough sizing, most of the residential units that are 40 to 80 gallons, a lot of them, their compressor capacity is 4.2 kBTU per hour. So you can take that 4.2, multiply it by 100, gives you 420. Well, most manufacturers, even the best right now, are recommending 450 cubic feet. So even though they've given you this formula and the option, you still have to use the greater of that formula or provide by the manufacturer. So in most cases, you cut to the chase, follow the manufacturer's recommendations. And even though that typically is a guideline, it's now a mandatory requirement that you follow the manufacturer's guidelines. A little sidebar, how to calculate the net free area. If you have a louvered door, you need to look at that. The quote unquote gap height is the space between those louvers. And part of these mandatory measures, if you have a system with the ducts, they're now kind of calling out specifically that the penetrations at the ceiling or the wall are sealed and that the ducts themselves have R6 insulation. Now, next we could kind of move into, that was sort of everything with the changes on the water heating for mandatory measures. The other little bit on the envelope is fenestration. Really, there hasn't been a change from the 2022 code where you can, most windows are going to use an NFRC rating. That was kind of the big takeaway for 2022. And now under the 2025, and I have a slide on it later on, because it shows up in a different part of the mandatory measures, there's now a weighted average U factor that you need to include with your fenestration, vertical fenestration. And so just kind of follow through with 2022, there's still installation and acceptance testing that's part of the mandatory measures. So that is included for all site-built windows. There hasn't been a change there. And then for these all occupancy equipment and building components, this is where they tucked in that glazing requirement I just mentioned. A lot of these kind of mandatory measures haven't changed that much, but from an architect's perspective, there is one area that I want to point out, and typically it was in section 120, or it was in section 120.7 called insulation requirements. They've now changed the name to building envelope requirements. And although they did add those windows in this section, building envelope, they also added vestibules, which I want to go over. I think is interesting for architects to kind of know. And then also included within this was the electric ready for the kitchens, and the section for ventilation outdoor air quality was really expanded. For horticulture, there's only one little update I noticed, which is increase in the efficiency for the lighting that's used for these grow rooms. And this is under covered processes. We haven't been doing too many of these anymore. There was a big rush for a while. It was popular. I don't know about the rest of you. So, you could chime in, but for the ventilation kind of mandatory measures, there's some new exhaust rates for veterinary facilities. So again, the code's getting kind of fleshed out more, but a lot of the changes aren't really dramatic. And there's been some minor variations in the way our outside air is calculated. So a lot of this is going to come down to the mechanical engineer you're working with. But I think as an architect, and I'm assuming a lot of the folks on the call are architects, actually, that would be a good thing. I didn't look at the registration. Typically, we have a lot of architects on the call. It's just a good to be aware of this, that there are requirements now for veterinarian practices. And there's been some new classifications like paint spray booths and refrigerated machinery rooms, but usually your mechanical engineers are working with that. And this just gives you kind of a visual, a table here. So the spaces then as an occupancy category, then if you know you're working on this type of a project, then you would expect your mechanical engineer to come back with meeting these mandatory minimum exhaust rates. When it comes to the outside air and how it is calculated, it's really similar. It's a little nuance change, and so the tables have changed. But basically, it's been simplified, really. So there's a new table, and now the minimum occupant load density is kind of labeled right off the bat for you to use, which matches more closely with the building code. And so there's a new number there. And then this area-based minimum ventilation is going to give you a number that's CFM per square foot, which is almost the same across from 2022 code to 2025 code. And then I give you a kind of an example of how to calculate both of those. And then you choose the larger of the two for the spaces. And in this example, I calculate it both ways. And the difference was just about 10 CFM. And most of the engineers are going to round up anyway. So I don't see that there's going to be any real significant changes that you're going to notice. But for your mechanical engineer, they're going to be calculating a little bit differently. Duct leakage testing. This is where for duct leakage testing, it was possible in certain circumstances where duct leakage testing was mandatory measure that you could use a HERS rater to verify that there was duct leakage no more than 6% per the reference appendices 7.5.3. Now, we're not going to, under the 2025 code, we're not going to use the word HERS anymore. So that's just kind of crossed out. But for non-residential occupancies, those reference appendices and the procedures listed in 7.5.3 have been updated, and they explicitly states that those procedures would be used by the installers and ATT or others who are required to perform, that testing. So an ATT is something that already existed in the code, but it's an acceptance testing technician as opposed to a HERS rater. So currently you could use this, you might see this form for non-residential. The H at the end of the title, NRCV MEC 04H, was for HERS rater. So I imagine this form's not going to exist under the 2025 code. Once they're done publishing all the forms, we'll know. But you would still have, your duct leakage testing and all the rest of the requirements that are to be shown with an acceptance test technician, ATT. Do you have anything you want to add to that, Grant? Have you been keeping up on this yet?
I'm curious what happens with the new code. It's still pretty hit or miss on jurisdictions requiring this. They are by code supposed to because there's enough licensed or certified acceptance test technicians in the state. That took a while for that to happen. So there was a long period when they weren't required. Um, I'm still seeing jurisdictions getting on board with understanding this as a requirement. I expect us just to see more and more of it as we continue.
Right. And then I forgot to highlight, but in the form on the left under intent, kind of the big paragraph in the middle, it does say that, you know, that HERS rater verification is permitted at the discretion of the project owner and authority having jurisdiction. And so I'm wondering if that will still be there, only they won't call it a HERS rater. You'll see it listed as ECC, Energy Code Compliance Rater. And so, yeah. So we don't know yet. If anyone else on the call knows more about that particular piece than us, put it in the chat, or we'll have you chime in at the end.
Yeah, Logan asked a question. Logan, maybe just reiterate your question. He's talking about the designation for the HERS raters. I just don't quite understand what specifically you're asking. You're asking if they're axing this or not. I'm not really sure. If you could just reiterate what you're asking, we can get that answered.
Are they?
Currently, HERS raters do this in the future? Question marks. Okay. Um, yeah, I think that's our understanding right now. And there are other RNC. Yes, there are other ones besides duct leakage. Correct.
Right. And some of it is, this is for the non-residential occupancies that are requiring duct leakage under certain circumstance. And for all our residential occupancies, it's going to still be the HERS rater doing all of it. It just won't be called HERS. I'm doing air quotes here. HERS. It's going to be called ECC, Energy Code Compliance Rater. They just gave it a new name. We'll talk about that when we get to the residential occupancy
And Jennifer,
presentations.
he's just clarifying that he's wondering if these NRCVs are going to exist at all. Is this just a change in, correct?
Yeah, that's my question also. And I'm just saying this is currently what you're going to see in 2022. And I unfortunately don't have a version of the 2025 forms to show you at this point. But as we kind of repeat this series, as we get closer and we get into the code, then I'll have slides for you with no underline, crossouts, whatever, and it'll actually be the real forms. I just want to give you a heads up that this is coming down the line.
Sorry, Logan. Wish we had a concrete answer for you at this point.
Answer. Yeah, and I wish I had pictures to show you that. I don't yet. Okay, so part of 20.6, there's a new mandatory measure. It's 20.6K, electric ready for commercial kitchens. And basically, the electric service panel is going to have a minimum capacity of 800 connected amps. And then the branch circuit conductor should be rated at 50 amps minimum. But the whole idea is that you would be able to swap out some of the fossil fuel burning appliances for induction and other electric appliances. For the section that was called 20.7, mandatory insulation requirements, there was just 3 things there: roof, ceiling, wall, floor soffit, pretty straightforward. Those mandatory requirements didn't change, by the way. But then under the 2025 code, it got a new name called mandatory measures for building envelopes. And then the two sections that got added was exterior windows and vestibules. So kind of this main takeaway here is that there's a weighted average U factor you have to meet for fenestration now, and public entrances, public entrance vestibules are required for some occupancy types now. So code language for the exterior windows is pretty straightforward. U factor no greater than 0.47. That's actually really easy to meet. And then you do have an exception, and that's if you're in a wildland urban interface or WUI fire area. And just for the fun of it, I went to this one brand of windows that I'm familiar with and pulled some of the specs on their product lines. And there's some product lines that easily meet the weighted average U factor, and then there are some that are much, much better. So it's really going to come down to probably your project costs, but it does seem like they recognize that 0.47 is an average weighted would give you kind of your most cost effective window that also could work with WUI. The one thing that I pulled that I thought specifically would be interesting for architects is that this new code language under vestibules is that the public entrances in newly constructed buildings of occupancies for assembly, business, educational, institutional, mercantile need to have vestibules, meaning you've got your entry doors and your exit doors. These doors would be self-closing, but it's a double entry. And I'd say a lot of us in California aren't used to designing that way for all of these spaces. But I do notice, like, even in Atascadero, when I go to my local, Petco and Target, there's vestibule entry for those stores. So it's the same kind of idea, but now it's a mandatory measure. Now, one thing you want to do, if you take a look at this section of the code, is you do want to read the exceptions first to see if this really applies to your building, and especially read number 7 for our tri-county regional area, because for climate zones 2 through 13, and remember we're in climate zones 4, 5, 6, 7, 9, right in the middle of it. It doesn't gonna apply if our building is less than 10,000 square feet and less than 4 stories. So we're really talking about bigger buildings. And then there's some other kind of things to note, like we're not talking about vestibule entries for sleeping units or dwelling units. And it's not required if the space it opens onto is all less than 3,000 square feet anyway. And it's not for doors, but it's possible you can use air curtains in lieu of the vestibule. So, and I think kind of interesting from an architect's perspective that would be mandated, because we usually think of that as a design kind of choice. But in this case, it was shown to be cost effective to have that extra set of entry doors for energy savings on these large buildings. Commissioning was required under 2022, still required under 2025. There's actually no changes to this section. I threw this slide in here, or kept it, just because like we were talking about with the acceptance testing, it's been required for a while, but there's been some lag in some of the implementation, and for some of the authority having jurisdictions for some of their areas. And so really there's a big picture pattern with the energy code is something gets introduced and then it takes a while before it really catches on. And then the next code cycle comes out and they don't change it. They just, okay, they're working on getting it implemented and catching on. So no changes for the next code cycle. And just kind of reminder, some of you may have been used to an old fillable form. Now everything is moved over to Energy Code ACE interview and form. And that can be found on Energy Code ACE non-residential forms website. And then I'm sure once they get all the forms and everything updated next several months, then you'll be able to start looking at the new 2025 forms. Okay, now we're going to go into some of the new construction, the kind of the prescriptive measures, and really it's related to performance in that anything that is in the prescriptive becomes the baseline for your performance method calculation. So section 140 really lays out all the prescriptive kind of recipe card things that go into a code compliant, energy code compliant building. And then section 40.1, it mentions the performance, and that's where it talks about all the new metrics that we were long-term cost savings metrics. Okay. And then the prescriptive approach itself really starts laying it out in section 140.3 with the building envelope, space conditioning systems, service water heating, indoor lighting, outdoor lighting, signs, covered processes, and your photovoltaic and battery storage. We're going to hit on a couple of the highlights just for those categories today. Well, so last time I did this, we were talking about updates for 2022 code. This was an excerpt of a table that showed the old numbers crossed out, the new numbers there, and basically what really was the big change is we had lower minimum U factor requirements for metal framed walls, where we need a lot of exterior insulation now to get those to pass. And then there were some other requirements for steep sloped roofs, and air barriers were now prescriptively required in all the climate zones. Okay. And then what that looked like for the metal stud walls to meet those requirements is, for example, if you had a 2x4 equivalent metal stud and you filled it with R13 or even R11 bat, if you put an R14 exterior insulation on it, you'd be compliant in all the climate zones. But that's fairly significant, the R14. It sounds kind of big, but when you take a look at what that looks like in construction, it's maybe not as bad as people think, because Rockwool Comfort Board, for example, makes an R12 insulation that's a couple inches thick, that's easily fastened with these kind of large plastic washers, and then a rain screen detail, and you can put tile or some decorative feature over that rain screen, and your insulation would be protected from the UV, and it would provide a thermal break for your metal stud walls. And then there was a little bit of update on the heavy mass walls, meaning 8-inch CMU solid grout. And so if you were to put an R5 insulation on that, it would work for all the climate zones. But for climate zones 2 through 5 and climate zone 10, basically just adding a layer of sheetrock would give you a code compliant CMU wall. And then really for your climate zone 6 through 9, those values would be indicative of just painting it with 2 coats of paint to meet your air barrier requirements. So not really earth-shattering on what you have to do, but in this particular case, I show an example of an R10 continuous insulation on that CMU wall, because this is where we got extra performance credit that we were able to use to offset something else. And then it left the metal stud cavity wall open for all the electrical and running everything else. And it was a clean installation. That's kind of how that project decided to move forward. Under the 2025 code prescriptive envelope, the new tables, you might look and see like there's a lot of crossed out values and a lot of underlined values. So basically everything that's crossed out is what's been improved or changed. And then only those metal framed walls and the heavy mass walls that we talked about for those central climate zones, that's about the only thing that didn't change. So what changed in 2022 that seemed like a big deal? Okay, they left it, and now they gave everything else a little bit of a boost on the insulation required. And let's just, for an example, we'll look at a wood framed wall for climate zone 4, and we need a 0.035 U factor, climate zones 5 through 7. We need better than a 0.095. And climate zone 9, same value as climate zone 4. And when we take a look at the joint appendices, we'll see that we could use an R4 insulation exterior with R21 or R22 and a 2x6 wall. And then that meets those requirements for the climate zones, 4 and 5. And then the other climate zones for milder climate zone like 6, you still only need a 2x4 wall. However, it used to be that you could use an R11, and now it's just bumped up depending on the climate zone, either an R13 or an R15. So not a big change, but a little bit of a change. And it's similar for the other wall assemblies. They all got just a little bit more insulation. If you go to this section now for 140.4 on space conditioning systems, under that, there's a lot of prescriptive measures that as architects, I don't think we would be that interested in it. I read the stuff, I kind of glaze over, but then I work with the mechanical engineers. This is their world. I put the list here so you can see everything that goes into it. I think for the architects kind of to realize is that under the 2022 code, now we're going to start to see dedicated outside air systems, those DOAS and exhaust air heat recovery. Okay. And under the 2025 code, now we have some specific mention of heat recovery, mechanical heat recovery for systems that use cooling towers, so they can recover some of the heat, waste heat from those cooling towers and put it into something else. And then really the system A types has expanded. We'll hit on that a little bit. And then those section R and section S I just mentioned are new, but it's really only talking about, roughly cooling that are 300 tons or greater. And then there's just a greater alliance with ASHRAE. So I think interesting for our mechanical engineers, but also, for the architects, just to understand that the equipment itself is moving in a direction to be more energy efficient. Now with space conditioning, the baseline under 2022 was a little bit different for each climate zone and occupancy type, but kind of the main takeaway is that wherever it was shown to be cost effective, heat pumps would be the baseline. So that part hasn't changed. And then what did change under the new 2025 code is that prescriptively, which again becomes kind of the baseline, prescriptively you could use VRF, which is variable refrigerant flow type of heat pump, and you could use what we were saying, that AWHP under the definition, the air to water heat pump with space heating loop and ventilation air that uses heat recovery. And for certain climate zones, you can use a hydronic recirculated air heating system. So a lot of words, what it means, like practically speaking for architects is like on a big project, you need to make sure that roof is laid out for your VRF heat pumps or your air to water heat pumps, and you have enough space for the dedicated outdoor air system. Okay, conceptually, what that looks like, just, you know, kind of architects conceptually, is you have one system, your dedicated outdoor air system that may or may not have some heating and cooling associated with it, but for our mild climate zones, a lot of times they don't. And then you would have your VRF or your air to water heat pump system that would then send the heating and cooling to your ducted air handlers inside the buildings. And not all those VRF systems are really large. Like, for example, this one, the picture here, that's like the back side of it, just these two together. It was about 4 feet wide, 5 feet wide, and maybe 66 inches tall. It's not really big. It was ground mounted and it worked for a winery, laboratory, and office space project we worked on. For the hot water, not a lot has changed. You can still use heat pumps to heat your hot water, but you can also still use gas under certain situations. But again, prescriptively, the baseline is to be a heat pump. And so that's what you would be compared to with a performance method. Under the 22 or 2025, the code language for the section didn't change at all, but it references the mandatory requirements, which did change. Then we kind of reviewed some of those. And the hotel motel occupancy type does follow the new multifamily requirements, which we'll get into when we do the multifamily course coming up. But otherwise, it's pretty much the same, and we're moving towards heat pump water heaters. Solar battery requirements for high-rise and non-residential occupancy types. Under the 2022 code, these were the occupancy types that were listed. And what has happened under the 2025 code is that we've got some new occupancy types, and we've had an increased amount of solar PV and battery requirements for some of those occupancy types. What that looks like, practically speaking, and there's a copy of the formula for you with an example how to solve for this. And the thinking is that if you know what that formula is and you have the table as an architect, you can get an idea of how much PV you're going to need, how much space you're going to need to accommodate. And one of the things under the current code cycle is that you could calculate the size or the capacity in kilowatts DC for your photovoltaic system based on the conditioned airflow area and climate zone factor based on occupancy and our climate zone. Or you could look at how much roof area you have available, solar accessible roof area, and multiply that times 14 watts per square foot. And then you choose one or the other based on which one was less. Under the 2025 code update, that kind of or alternative based on SARA, the solar accessible roof area, it's changed a little bit. So it's still 14 watts per square foot if you're on a low slope roof, but they've added a 18 watt per square foot requirement for steep sloped roofs. Otherwise, the section's pretty much the same. And it's still true that if you have a mixed occupancy, then you would apply this formula to each of the occupancy types and add it together. And there is some exceptions if you have a tenant space that's completely separate. It's a little nuanced, but that's the basic idea. So this table was used for the 2022 code. Fairly straightforward. It was by climate zone. You find your climate zone at the top and then find your occupancy type, and then you use this factor in the formula. Now, for the 2025 code, that's going to use that same formula, but now they've just kind of broken out the climate zone separately across the top of the chart, and they've listed all the building types plus the new ones there. So I've noticed that some values have gone up quite a bit, like restaurants, for example, have more of a requirement than under the previous code, and some of them have remained relatively the same. I put this slide in here just as a reminder of the solar accessible roof area is any roof area that has more than 70% annual solar exposure and space that is open and free of equipment. If you need the area for access for fire on the roof, that doesn't count, but all the rest that gets sunlight counts as your solar accessible roof area. I put this in here as an example of how to estimate the quantity of panels, because a lot of times folks, it's like, okay, I see how I can calculate what that PV system size is, kilowatt DC, but now what? And just as an example, you could use this panel as kind of an estimate because it's got dimensions, and kind of use a rule of thumb for allowing a little space between the panels. And you can take that size requirement for the panel and divide it by 470 watts and get an estimate panel size. And then you could start to see how you might lay it out for your project. For your battery requirement, all the buildings that are required to have a PV system shall also have a battery storage system, unless the battery storage system is so small that you meet one of the exemptions. But generally speaking, if you're going to have a big PV system, you're going to need a battery system. And there were two formulas you had to follow, energy capacity and a power capacity. And probably the trickiest part of the formula is what was called D, the design, the rated single charge discharge cycle from AC to AC. That you have to pick up from manufacturer, but if you want to just get a real rough idea, you could use a number between 0.8 and 0.95 for that value, because that's pretty common. And D, that is to the power of 0.5 or the power of 1/2. And so you would look up these values in this table. Now, under the new code, the formulas have changed. It's now based on the conditioned floor area, and they're using a factor B for your BESS or your battery energy storage system from a different table. And then the rated power capacity is more simple. You just take that kilowatt hour value from the first formula, you plug it into the second formula and divide it by 4. So they simplified the rated power capacity. And then they also gave folks for their battery size what's called a SARA adjusted rated energy capacity. So if you are taking that SARA exemption for the PVs, or that SARA alternative, I should say, for the PVs, then when it comes time to calculating your battery, you're going to use this other formula where you use a ratio for the kilowatt PV size for SARA divided by the value without SARA. And, you can also get help from your code coaches and probably your electrical engineers on this. But I put it in here for your reference. And then this comes with a new table for those BESS factors. Again, based on the climate zone and occupancy types. And then this is kind of what some of these battery storage systems would look like. And if it's less than 10 kilowatt hour rated capacity, you don't need it. You qualify for the exemption. And kind of the biggest thing I noticed with the 2025 update is now Climate Zone 1, the no battery storage system for office, school, warehouse, that exemption has been removed. So Climate Zone 1 now has been kind of brought into the fold with the rest of the climate zones. And then this just gives you kind of an idea of conceptually where this battery system kind of fits in with the grid and your PV system and the rest of the building, and also just for the architects visually to see that these larger batteries are, it's one module, one unit system that's set into place, as opposed to thinking of residential scale or really small commercial scale where you might have like a series of power walls. And this form, the NRCC for our solar system, it's required. Again, you go to the Energy Code ACE tool or the Energy ACE tool and follow the tool interview, and you would have your solar and battery Title 24. And then the other kind of nice thing to know about is that under the performance method, and this is an excerpt from Energy Pro 9. So this is for the 2022 code, is that you can use extra battery for helping to reduce the carbon kind of source metric. So a lot of times we'll see projects that use the performance method, the architects and the development crew, they have certain ways they want to construct the walls or certain windows, and they may be looking for a way to trade energy features on and off in the performance method. Or commonly what we see on large projects is the mechanical engineer perhaps is not that familiar with the heat pump water heating technology systems or spaces, or is limited on space, extremely limited, and wants to go with a gas boiler, but that boosts that source carbon metric and takes it out of compliance. So in some cases, it's possible to then use extra battery storage to help offset that metric. And then this just gives you an idea of the kinds of values we're putting into the software and the information we would need to know about that battery system. And then last but not least, if you have questions on any of this and want more information, Grant is available and I'm available as code coaches, and you can reach out to us online or call us directly. And with that, I'm going to turn it back over to our host. And if we have a few minutes left, we are happy to answer questions.
Thank you so much, Jennifer. And yeah, what a great course. Thank you again, everyone, for coming. And thanks to Jennifer and Grant as well for continuing to answer those questions. We will be sending out a survey to your email in the next several days. Please fill this out and provide some training. It's really helpful for us when we're scheduling future trainings. And if you would like to see more like this in the future, please provide that feedback as well. We're always developing new trainings, so if you have any ideas for new topics, that would be great to include as well. And it should only take a couple of minutes. As I mentioned, and as Jennifer mentioned earlier, there are learning units for this course. I will drop my email in the chat, and if you have any questions, please reach out to me. And a reminder that we will be using attendance records from today's Zoom to distribute it. So if you joined in from someone else's laptop or your phone, please email me to confirm your attendance. And lastly, just want to highlight some upcoming courses that we have. So we have a couple more next week on heating and cooling, energy storage, and we have a couple of in-person events coming up as well. So if you're interested in that, please look at our website, 3cren.org. And with that, I'll pass things back for any last-minute questions.
Yeah, feel free to unmute too if you have a question. If it's too tricky to type. Let's see, I could end the slideshow and then we can see if we could see if there's people there who are, okay, now I can see all the people in the, and any questions or typing, or if anyone has any questions and is brave enough to unmute, feel free. Were there any questions in the chat that came up, Grant, or did we get some of those answered?
We addressed them, but pretty light questions today for your presentation. I know there's a lot of information in this one, so
It is, yeah, the
ask
non-res
questions when
one,
you're
I think
taking in
in a
so
way
much.
is kind of tricky because especially as architects are like, okay, you need to know about it, but so much of it, you're going to work with your mechanical engineer, your electrical engineer. So I tried to highlight the things that I think would be most important for the architects to know about, could help improve your ability to just know kind of what's coming up in your design and just to understand some of the equipment types. And then next week we'll have a course on batteries, and that'll deal a little bit more with residential scale and kind of multifamily scale, give you a little bit better idea about that. And then the rest of the courses for this series will get more, I think, a little more in details of what a lot of the architects know, because they'd be more in charge of everything in a residential project, residential scale. A lot of times, especially on your single family, you're the one who's going to be helping your architects figure out if they're going to do a heat pump water heater or a heat pump space heater, or looking at new technology like the monoblocks, stuff like that. We'll hit on that.
Did get a question just now from Edgar for PV requirements for a building occupancy type that's not listed on the table. He's got a enclosed amusement attraction structure.
Yeah, if it's not listed, it's not required. So you want to double check and kind of read the list carefully. I noticed the first time I read the list, I accidentally missed library, was sort of grouped in with the stuff at the bottom. And so I was like, oh, under the new code, they added library. And what it was is, oh, under the new code, they kind of pulled library out by itself and expanded the requirements. So just read the list carefully, or, you know, contact us also, and we can go through that list with you and kind of double check if it's required. But if it's not there, then it's not required.
And then closed amusement attraction structure is that's pretty unique. I don't think that will pop into any of the occupancies.
No, I don't think so either. I think you're good. I think you're safe. Yeah, unless somehow your authority having jurisdiction goes, oh no, that's a type of warehouse. But I don't think so. It wouldn't meet the definition. I'm just kidding, by the way. I probably shouldn't joke about the code. That would really mess people up. Yeah, no code jokes. Well, okay. I think I want to make sure everyone can get on with the rest of their day and not be late for anything. I appreciate folks being on the call and hanging out for the questions, and hope to see you on the other courses. Thank you, and thanks for the nice comments in the chat. Appreciate it.
Yeah, thank you all so much for attending, and thanks again one more time to Jennifer and Grant, and have a great rest of your day.
Bye, everyone.